Now let us start this new chapter, wave optics, chapter number 7 from our SY-07 syllabus. Actually, last year in 11th standard, we have considered some part of the light section. Optics is the another name for light section. So in that part, we have considered the different laws governing the formation of the images by lenses or mirror equation, lens maker's equation. Then we have seen magnification process, magnifying power of different instrument, etc. So that part we have completed, and in that part we have used the geometrical optics. The ऑब्जेक्टिव्ह पोझिशन माहिती असेल तर इमेजची पोझिशन आपल्याला डिसाईड करता येते, त्यासाठी फक्त यू व्ही एफ वगैरे मधले रिलेशन आपल्याला माहिती पाहिजे. सो वी हॅव स्टडीड दॅट रिलेशन. सो इन जनरल ऑप्टिक्स मीन्स लाईट. सो दिस ऑप्टिक is divided into the two parts. Already we have seen this classification. So we will just introduce what is meant by wave optics. So optics is the another name for light. जसं आपण साऊंडला ॲक्वस्टिक पण म्हणतो. Acoustic is another name for sound section. Optics is another name for light section. So this optics is divided into the two parts. One is geometrical or ray optics. Ray optics. And other one is a wave optics. This is the title of our chapter. Wave optics or physical optics. Physical optics, like this. Geometrical optics or wave optics, wave optics or physical optics. So we know the meaning of this ray. What is meant by ray? Light always travels along a straight line path. Straight line path with a great speed, c equal to 3 into 10 raised to 8 meter per second. So this straight line path is called a ray of light. Definition of ray of light. This straight line path along which light propagates or light energy is transferred is called a ray of light. The straight line path of the light energy is called as a ray of light. And if we consider the number of rays together, then it is called as if we consider the bundle of ray of light, then it is called as the beam of light. A bundle of rays of light is called a beam of light. A beam of light. Generally, for image formation, we always draw a ray diagram, and in that ray diagram, we are using generally only one ray of light. Only one direction is considered, and then how it is reflected, refracted, etc., that can be studied like this. So this is about the ray optics. This ray optics is useful in understanding the phenomena like this. Uses of ray optics to explain rectilinear propagation, in short we will call it as a RP. Linear means along the straight line, rectilinear propagation, reflection, refraction, double refraction, dispersion, total internal reflection, TIR, total internal reflection. But there are some new phenomena discovered in 19th century like interference, diffraction, etc. These phenomena cannot be explained by using this concept of ray of light. So, for that purpose, we have to consider one more types of optics, and that is called as a wave optics or physical optics. So, what is meant by wave optics? The name itself suggests that in this case, the light travels in the form of electromagnetic waves. So, what is meant by wave optics? Definition of wave optics. When propagation of light energy is considered in the form of electromagnetic waves, EM waves. In short, we will call it as EM waves. When the propagation of light energy is considered in the form of electromagnetic waves, then it is called wave optics. Then it is called wave optics. this is the difference between the ray optics and wave optics. Here we are considering the propagation of light energy in the form of electromagnetic waves. Here we are considering the rays of light like this. So these are waves, these are rays. The name itself suggests that. Now this phenomena can be used to explain this phenomena. Uses to explain interference of light, diffraction, polarization, diffraction, polarization, Doppler effect. Etc. Like this. So now what we can conclude, some phenomena of light are explained by using ray optics, where we are using particle nature, while some phenomena are explained using the wave nature, and therefore we have to consider the dual nature of light. So light has both type of nature. So now we have to consider the nature of the light. So we have discussed about this nature of light last year also. Here we have to see it in detail. So two types of nature of light are used even nowadays. So the types are like this. One, wave nature of light. Wave nature of light. So the name itself suggests that light is traveling in the form of electromagnetic wave. Light is a form of energy. We know different forms of energy: light energy, sound energy, heat energy, electric energy, mechanical energy, kinetic energy, potential energy. There are different types of classification of energy. So light is a form of energy traveling in the presence or absence of a medium. Light is a form of energy traveling in the presence or in the absence of the medium. Light can also travel in vacuum. So last year we have seen that Maxwell has suggested the concept of electromagnetic waves. Electromagnetic waves are generated by very simple arrangement. फक्त एक चार पार्टिकल घ्यायचा आणि तो फक्त ॲक्सिलरेट करायचा समजा. So when the charge particle has acceleration, it radiates energy, and that energy is in the form of electromagnetic waves. So we know the nature of the electromagnetic wave. In electromagnetic wave, this is the nature. If the wave is traveling in this direction, this is the direction of propagation. Then this is electric field vibration, these are magnetic field vibration. These two vibrations are perpendicular to each other, they are also perpendicular to the direction of wave propagation. So these two are oscillating electric field. They are not steady field, they are oscillating electric field. So, like this is the nature of the electromagnetic wave suggested by the Maxwell. So, according to Maxwell, according to Maxwell's according to the Maxwell's electromagnetic theory, light travels in the form of electromagnetic waves. We will use this short form, electromagnetic waves. This is called wave nature of light. Wave nature of light. This is called wave nature of light. This is one nature. So, particle nature is like this. According to the Planck's quantum theory, the radiation like light propagates in the form of a stream of quanta, that is particle. Each quantum is having finite energy. We already know this equation. Energy of the each quantum is equal to h into nu, where h is a Planck constant and nu is the frequency of radiation. So, Einstein named this particle as photon particles. So, this is also called as a photon nature or particle nature. Named this quanta as the photon particle, like this. So, first we will consider this particle nature in detail. So, Mosley has suggested, the scientist Mosley has suggested the particle nature initially, and it was developed by Newton, and therefore it is also called as the Newton's particle theory or Newton's corpuscular theory, like this. So we will start for this. So we will see this particle nature in detail. Particle nature of light. Firstly, it was suggested by Mosley. This nature of light was first proposed by Mosley, and then it was developed by Newton. So Newton has suggested corpuscular theory in 17th century. Actually, this theory was accepted in those days because all the phenomena known to us at the time of Newton in 17th century were explained satisfactorily by Newton, but then in 19th century this theory failed. So today we are not using this theory because it cannot explain some new phenomena of light like this. So particle nature was accepted temporarily only. So what are the suggestions by Newton that we have to see? Corpuscle, it is another name for particle. It is the Italian word for particle. So corpuscle means particle. So it is particle nature. So corpuscle means particle. So it is also called as a Newton's particle theory or Newton's corpuscular theory. So we will start from this, like this. So let us see this Newton's corpuscular theory in detail. What are the suggestions made by the Newton and how he was able to explain to some phenomena of light that we have to see. So what is exactly light? That nature of light was mysterious thing. So it was tried first by Moseley. He suggested that light travels in the form of stream of particle. These particles has Latin word corpuscle, and therefore Newton had developed this theory. So what are the assumptions? What are the postulates made by Newton about this particle nature that we have to see? So according to the Newton's, this light travels in the form of stream of particle, corpuscle, and for this corpuscle, Newton has made some assumptions like this. So the first and main assumption is this. According to Newton, light travels in the form of stream of corpuscles. Corpuscles, that is particles which are minute, very very small, cannot be seen by naked eye. Hard, that is rigid, elastic, and massless, negligible mass, like this. So these are the assumptions. The particles are very very small in size, like this. Minute, very very small, hard, that is rigid, elastic, and massless. So they are elastic. Therefore, when these particles are incident on any surface, then they are reflected back during the collision, and those collisions are elastic collision, perfectly elastic collision, like this. So these are the first assumption. Now these particles are emitted by a source of light. It is due to the high temperature and they move along the straight line path. Second point, these corpuscles are emitted by source of light. This source of light is generally hot body. Source of light. These corpuscles are emitted by source of light and they travel along a straight line path, like a bullet. So we know mechanics. When the bullet is fired horizontally parallel to the surface of the earth, first it travels along the straight line path, and then it bends its path toward the surface of the earth, and finally it falls down. But up to a certain distance it moves along a straight line path. Why? Because in that case applied force is larger than. So we can add one more point here. They travel in the straight line path like a bullet in the absence of any other force. In the absence of any force. Any force. So energy is given by any external force. Energy is given by the soul, and because of that energy they move like this. For example, if this is a sun as a source of light, this is the earth. So because of its high temperature source, sun is a high temperature source. So these corpuscles are emitted and they reach the surface of the earth like this. So this is a stream of corpuscles. This is the second solution. Then third point. Third point. When these corpuscles enters our eye, these particles enters our eye, they are incident on the retina. When these particles enters our eye, they produces sensation of light because of their energy. They produces sensation of light like this. Now, at the time of Newton, the phenomena of dispersion was known. Actually, we know that the phenomena of dispersion is due to the different wavelength, because wavelengths are different for the light, therefore refractive indices are different, therefore angle of deviations are different, and therefore the light emerges in the form of the spectrum consisting of 7 constituent color: red, orange, yellow, green, blue, indigo, violet, etc. आपण प्रिझम मधून होणार डिस्पर्शन स्टडी केलेलं आहे. So 7 colors are observed in the light. This phenomenon was also known at the time of Newton in 17th century. But the explanation given by the Newton was wrong. He suggested that there are 7 different sizes. There are 7 different sizes which produces the 7 colors. So next point is this. There are 7 different sizes of particles, corpuscle, which produces 7 different colors of light. Colors of light. So why we get 7 different color, why we get dispersion, the Newton has explained this, but this explanation is wrong, like this. Now, one more point. Now when these corpuscles are incident on a reflecting surface, then it gets reflected back in the same medium by obeying the law of I is equal to R, angle of incidence is equal to angle of reflection. So when the light corpuscles strike the reflecting surface, they undergo elastic collision. As a result, they follow the law of reflection. So he assumed that there is a force of repulsion between the particles of the medium and like mirror and corpuscle. So next suggestion was like this. Five. Newton assumed force of repulsion between corpuscles and particles of the reflecting surface. So if this is a reflecting surface, then this is the source. So this is the stream of particles and they are reflected back obeying the law of reflection. This is equal to R, this is equal to R. So these are corpuscles. So Newton has explained like this: when the corpuscle strikes the reflecting surface, then they undergo the elastic collision and follow the law of reflection. So expression was given like this: that is, when corpuscles strikes the reflecting surface, they suffer the elastic collision. They undergo elastic collision and bounce back in the same medium following law of reflection. Like this. So why reflection takes place? This is the reason. Now there is one more phenomena. During a refraction of light, the force of attraction between corpuscles and particles of the denser medium. Particles of the denser medium is predominant. Is the predominant and which changes the direction of ray of light, direction of light. This is called a refraction. This changes the direction of light obeying law of refraction, like Snell's law. Like Snell's law. So, refraction and reflection phenomena were proved by Newton like this. हे न्यूटनच्या पिरियडमध्ये जे काही फेनॉमेना माहिती होते ते सर्व या पद्धतीने आपल्याला एक्सप्लेन करता येतो. Like this. Now, these are the suggestions made by Newton about the particle nature of light. Now, what are the merits or what are the advantages of this theory? That now we have to see. So, this Newton's theory was suggested in 17th century and it was accepted by the people. Why? Because it has certain merits. At the time of Newton, some phenomena of light were observed and they were explained satisfactorily. These phenomena are rectilinear propagation, reflection, refraction, dispersion, etc. And therefore this theory was accepted in those days. So merits are like this. Newton's theory can explain rectilinear propagation, of light, a reflection, a refraction, dispersion of light satisfactorily. And therefore this theory was accepted. But after 18th century, when some new phenomena were discovered, this theory failed. So what are the demerits or drawbacks? Demerits, oblique drawbacks of Newton's theory. So drawbacks are like this. If we consider the particle nature, then when particles are given out by any source of light, then its mass should decrease. But practically there is no decrease found in the mass of any source of light. So this is first drawback is like this. If light is emitted in the form of particles, then there should be decrease in the mass of source of light. Experimentally, no such reduction, in mass of source is observed, and therefore this theory fails. The severe drawback was like this. Newton predicted, without performing any experiment, Newton predicted that speed of light in denser medium is greater than speed of light in rarer medium. Speed of light in a rarer medium. Fusey was Dutch physicist. So he measured the speed of light in different media, and the experimental result was like this. Experiments by Fusey. We can use this experiment even though nowadays. Experiment by Fusey shows that speed of light in denser medium is smaller than speed of light in a rarer medium. Therefore, result of Newton's theory is contradict result of Newton's theory about speed of light. Speed of light is contradictory, means opposite. Contradictory with experimental results. Experimental result कोणी पण व्हेरीफाय करू शकतो, इव्हन आपण आज पण व्हेरीफाय करू शकतो. Experimental results like this. So this is one more severe drawback. The result about the speed of light given by the Newton is wrong. Predicted means without performing any experiment, Newton has suggested that speed of light in denser medium is more. Practically it is wrong, like this. Now, the Next drawback is like this one. So just now we have seen that reflection takes place because of force of repulsion. A refraction takes place because force of attraction. So there is a one more phenomena like simultaneous reflection and refraction. We have seen in last year also. जर आपण एखादी ग्लास प्लेट जर घेतली आपल्याला ग्लास प्लेटच्या मागचं पण दिसतं रिफ्रॅक्शन आणि त्या ग्लास प्लेटवर रिफ्लेक्ट होऊन लाईट परत पण येतो रिफ्लेक्शन. सो सायमल्टेनियसली both the phenomena are taking place on the surface of the transparent glass plate. Reflection as well as refraction. This is called as a partial reflection, partial refraction, or it is also called as a simultaneous reflection, refraction. So this phenomena cannot be explained using the Newton's assumptions of force of attraction and force of repulsion. ग्लासचे पार्टिकल एकाच वेळी कॉर्पस्कलला रिपेल पण करतील आणि अट्रॅक्ट पण करतील. सो दिस वॉज वन मोर ड्रॉबॅक. The phenomena like partial reflection, partial refraction, partial reflection, that is simultaneous reflection, simultaneous refraction cannot be explained using assumptions of Newton's theory. This is one more drawback. And like this. So these are the drawbacks. One more drawback is this. Some new phenomena of light like interference, diffraction, polarization, double refraction, cannot be explained using Newton's theory. So what is the conclusion? Because of these four drawbacks, Newton's theory was discarded. So the conclusion is this: because of these drawbacks, Newton's corpuscular theory, it is not used further. फक्त आपण हिस्ट्री म्हणून ही थिअरी बघतोय सिलेबसमध्ये. बिकॉज ऑफ दिस ड्रॉबॅक्स न्यूटन्स कॉर्पस्कुलर थिअरी failed. It was discarded, thrown off. So nowadays we are not using this corpuscular nature. No doubt light has particle nature, but that nature is photon nature, and photon nature is completely different from corpuscular theory. दोघेही पार्टिकल थिअरीज आहे, पण इथे आपण कॉर्पस्कल नाव दिलेलं आहे, त्याचे ॲशम्पशन न्यूटनने सांगितलेलं आहे. फोटॉन पार्टिकल्सच आहे, पण त्याची साह्याने आपल्याला बऱ्याच फेनॉमेना एक्सप्लेन करता येतात असं लाईक दिस. सो दिस इज अबाउट द न्यूटन्स कॉर्पस्क्युलर थिअरी. So we have seen the types of optics, wave optics, physical optics and geometrical optics like this. First we have seen the properties of these geometrical optics and wave optics. Now the name of the chapter is wave optics, therefore we are going to see this wave optics in detail, but for that, before going to this, we are considering the nature of light. So this is one type of nature that was assumed by Newton. Light travels in the form of particles which are minute, very very small in size, cannot be seen by naked eye, hard, rigid and elastic in nature and massless, like this. So Newton has made some assumption. Using this assumption, he had explained some phenomena of light. Those were accepted by people in those days. Nowadays we cannot accept this Newton corpuscular theory. Why? Because of these four drawbacks like this. There is one or two simple experiments which shows that this Newton corpuscular theory is wrong, and what is the new theory that we have to see. Okay, we'll stop here.